All right then. So it's been a while, eh, since we did this. So in question number one, we have you remember these are fractional exponents. It's been a little while. So do you guys remember how to tackle things that have fractional exponents? Kind of. Yeah, it's like a right. Good. Okay, so you knew what you meant. Very good. So let's go over at least the first two. I'm thinking probably the first three, maybe four. You could talk me into a few if you want. It doesn't matter. So we have 81 and x squared, and that whole quantity is being raised to the power of 1/2. I feel like the first thing that we should all agree on is that when you have an exponent like this, whether it's a fraction or not, you should be thinking about distribution. So you should take this exponent here and say, I'm going to give it to that 81. And don't forget, I'm also needing to give it to that. Like we've talked about that, like properties of exponents. So the 81 is going to get a power of 1/2. And then the x is also going to get, now mind you, it's already an x squared. Like it was that at the beginning, and then we give it the power of 1/2. So I'm going kind of slow here, like I said before, because it's been a little while since we've done this, right? And get that little guy out of the way there. Ah, go good. So, all right. So back to what Hunter was talking about, and so we got to remember that when an exponent is a fraction, the different parts of the fraction each have different jobs to do, right? So we all, I hope, remember that this bottom number, I'm circling him in red, he determines the type, the index is the word we use. He determines the type of root we have to build. So I'm going to take the number 81 and I'm going to place it inside of a square root. And you also recall that you don't have to put the 2 here. It's not wrong. It's just really weird. Like if we don't put a number up there in the index corner, then math people just always know that it's a second root, a square root. So then we're going to put the 81 inside. And then what, remember, does the 1 do? The one that I'm circling in yellow. It waits. And when it's done waiting, what does it do? It doesn't multiply. What? No, it exponentiates. So it's, I know you're used to like properties of exponents where that would mean times, but what it is it becomes the exponent like up here after you're done with the root down here. That'll be more relevant in the next couple problems, but that's what the numbers of a fractional exponent do. They just kind of high five and then go their separate ways. The bottom number goes and makes a root, the top number goes and makes a power, and then they work together at the end. So what is the second root of 81? And 9 to the 1th is, well, 1. 9, right? So we have 9. Good so far? Yep. All right, now we're going to take the XE part, and this one we have to actually do multiplication. And you had said this before, but now it's an appropriate and correct answer because these two numbers in the green box are both exponents. And when you exponent an already exponent, the properties tell us that we have to go times. So we got to bust out a little fourth grade kiddie math here. What is 2 times 1/2? It is just 1, right? Because you could put the 2 over 1, cross them out, however you want to do that. It's going to equal 1. So we wind up in the end with just getting x to the power of 1. And of course, you probably wouldn't put that, right? Just 9x would be just fine. Is that coming back to you a little bit? All right, let's take a look at problem 2. A little bit more meat on this bone. What's the first thing that catches your eye? As I copy it down up here, what's the first thing you notice about problem 2? There's a negative exponent, right? And we got to give that just full respect, right? That we're not gonna say something rookie like, you know, it makes the answer negative or something. What do negative exponents do? Yeah, they flip things, right? And if it was already on the bottom of a fraction, it would flip it back up. But like in this case, all that stuff you see, the 100 in the end, those are upstairs. They don't look like it, but they're upstairs. So that negative exponent's going to move them down. So go ahead and take a moment and distribute that exponent through. Don't do any math though. Like don't calculate what anything actually equals. Just take the power and shoot it in. So if you shoot it over here onto the -3/2, or onto the 100, excuse me, like this, then you just get this. You get 100 to the -3/2. And one of the hardest parts of my job this year, and then when I see you again in Algebra 2, is to train into you the idea that negative exponents do not make answers negative, right? They have nothing to do with that. So we'll get back to that. And then we're going to take the -3/2, and we're also going to distribute it to the n. And just like before, we have a variable that already has his own exponent, and then we give it like an additional exponent like this. So having done zero mathematics at this point, I'm just ready now to calculate each of those separate parts. So let's talk about, first off, I think we should, personally, I think we should clean this up. I feel like that's something we can do. So what do we do again with these two exponents? Multiply, right? And again, this should be simple at this point in your life to do something like 2 times -3/2, right? Simple math, what do we get? Yeah, yeah, it's just don't ever, this is -3. Never ever fail when doing a multiplication problem to look for things that cancel. I'm telling you, man, that's huge. So if you just kill those twos, then all you see is -3 and you're like, perfect. So I'm going to get rid of this thing in the yellow, and I'm just going to make the new and improved version of itself, which is n to the -3rd. All right, so now we assess the landscape and got some things to consider. Both of the things we see have negative exponents. What's that mean? If they're both going to be on the bottom. So when this problem is over here in about 30 or 40 seconds, like it's going to be bottom heavy. There's going to be nothing left on the top because the 100 says, I got to pack up and head down. And the n says, hey, I'm coming with you there, Holmes. Like we're both going down. So when we talk about the final answer, it's got to look like this because there's nothing left on top, right? All right, so let's talk math. When we get the 100 downstairs, it is going to be 100, but its new exponent is going to be +3/2. Yay, happy day. So refresher, again, what does the 2 that I'm circling up here do? It's the index, right? It gives you the flavor of the root that you're being ordered to use. So we have to do a second root of 100, which we lately have been calling a square root because we're normal people. And then what, remember, does the 3 do? He waits, but he waits in a very particular location right there. He kind of lurks up waiting for us to do our thing on the root. So what is the red, bless you, what's the square root of 100? And what's 10 to the 3rd? 1,000. Not 10 times 3, 10 to the 3rd, right? 10 times 10 times 10 is 1,000. So we got part of our answer placed. And then the n, of course, is easy. We would just stick it downstairs and give it a positive exponent. No math to do. We already did all the math on the n. Now I'm going to go over number 3. And the reason is because I did those with first hour, and then I got a lot of questions on number 3. And my teacher sense told me, dude, you probably should have gone over more than just the first 2. So let's go over number 3 and anything else you want, and then we'll just be work time, I think, after that. I can go over problems on the back, but like I said, the back is what we're doing right now, so you probably are pretty fresh on that. But anyways, let's do number 3. So we have the quantity of 27x to the, or k to the 6th, and we're going to raise that whole quantity to the power of 4. Third verse, same as the first, right? Like here we go again. So we're going to take the exponent that's on the outside, and we're going to say, I shall apply myself to you, and I shall apply myself to you. So in the interest of not going too fast, I'm just going to show what it would look like without doing any math. It would be 27 to the power of 4/3 times k to the already 6th power raised to the 4/3. All right, let's do it. See if we can be quicker this time. First off, no negative exponents, so this answer is going to be all top, right? No one's going downstairs this time. So what is quickly 27 to the 4/3?
9 to the 81.
It's 81, nice and quick. Let's talk about why that is. What does this 3 mean again? It's the index. It's the cube root of something, and that something is, of course, the base 27. And again, the 4 says, let me be your power. So I wound up showing my work anyways, but still pretty quick. What's the cube root of 27? And what is 3 to the 4th? And that's why this portion becomes 81. Very good. It's not square rooted, it's cube rooted. And so you might want to bust out if you don't have it out, remember the sheet I gave you a couple weeks ago that has all your roots on it? So if you look at that, and you might already know this, but the cube root of 27 is 3, not the square root. Okay, so that's what changed is that index number. I'm going to put purple around it up here. This number, remember, determines that we got to switch now from that jumps us around from root type to root type. So then it winds up being 3 to the 4th. That's why it's 81. You good? And again, we have to resort to some little kitty math here because inside this red box are 2 exponents that have to, again, be multiplied together. And so 6 times 4/3. I taught you the hook earlier this year. I hope you use that whenever it's appropriate to hook this one. And again, we call it the hook because it kind of looks like a little fish hook. Yeah, it's 8 because you do 6 divided by 3 is 2. Swing it up, 2 times 4 is 8. So right next to the 81, we just stick a K to the 8th. People say something like, I don't understand the hook. Then my answer is like, then don't use it. Like, I don't care. Do your math like you did back in grade school. Put the 6 over 1, multiply it by the 4 over 3, and then use whatever method someone taught you. Multiply then reduce, or reduce then multiply. I don't care. Do you have anything else on the front page look like it's worthy of concern? I mean, I'll keep answering your questions throughout the hour, obviously. I'm just, while we're in this setting, is there anything else? Yeah. Go ahead.
Exponent, it's dividable.
Divisible? Are you talking about this one that I'm pointing at right now? That's not relevant because it's not inside of a root. If it were inside of a root, then I would care. But once, like, we're not rooting here, like that's not what that's all about. Are you with me? Good thinking. And that thinking that you just employed, that'll be real beneficial in the back. Because remember, the back, that's where we're worried about those even exponents, right? But not the front side.
Oh, wait,
I know, but again, I don't care. I don't mean to sound rude. So usually when people say I don't care, they're being rude, but I'm not trying. I just don't care because this answer, well, it's not about not being necessary. It's about, like, imagine just for a second, and I know this is going to seem really weird, but imagine you were taking a math test and your teacher said, okay, I need you to do 2 + 2. What would you say?
4.
Then would you stop to go, well, but wait, 4 can be square rooted, and then tell your teacher that the answer is 2? Right. I know it sounds crazy, but that's kind of what you're trying to pull on me is you're taking an answer that's in the purple box and trying to square root it for some reason when you shouldn't be. There's no square root to be had here. We've already done all that stuff.
What you just said, is there anything else to do?
There would be if it were inside of a square root sign. Then we'd put 9K to the 4th if it were, but it's not. So it is what it is. I don't fail to understand your question. It's a good question, but don't get confused between the front page and the back page. Okay. Yeah. Yes, you do. You can remember that a couple different ways. When you go down, that starts with D and so does divide. Or you can remember that it's alphabetical. D comes before M in the alphabet, so divide before you multiply. Anything else? Like I said, I'll keep this recording alive, just paused. If you have more that you want to go over, let me know. If anyone's interested, number 25, here you go. Come on along for the ride. This one is going to wind up being an answer that has no square root when we're done. So the reasoning behind this is, again, we always want to check everything inside. So we want to start by looking at the number 324. And remember, job 1 isn't to say, how do I break it down? Job 1 is to put it in, look at your notes and say, is it on the red list? And is it? It is. So, and this the second time, right? So that's something you need to keep looking at a little better is say, like, I got to look for those red list numbers. So the square root of 324 is just already 18. And then the square root of x to the fourth is just x squared, so like done. No, it's too soon for that. I'll get it up probably tomorrow. Okay. Let's do another one. I think I want to go over problem number 34. You down with that? That sound good? Okay. And then I think I'll be done probably with the recording after that, unless you have any other questions. So number 34 is a good example because it has a little of everything. So it starts with an already jailbroken number, which is great. And then on the inside, we have a number 490 that is not red list material. So this is good practice for us. And then we have a nice x to the even and a nice y to the odd. So this is a great sampler platter for us. So how are we going to start by breaking down this number 490? And I would tell you to look at the obvious. It ends in a 0. It's not always, and that's good, isn't it? Because 10 is garbage and 49 is perfecto. So when we go to, because remember with this back page, what we're always trying to do is we're trying to rewrite the problem so that the things inside are either red or white, like in my case, or in your case, circled or not circled, or something like that. So I'm going to take the 49, make it red because it's good. And then the leftover, the 10, bless you, will be white. Tell me, what do you think about the x squared? Yeah. I'm going to leave it like that and make it red.
Y times 4, or
Y to the fourth times.
times.
Good job. So again, my red things, your circled things, however you do it, we identified that the good guys are coming out, right?
Right.
So when 49 flies out of jail, what does he become?
7.
But then you multiply him by the other jailbreak, and what do you get?
-42.
Negative 42?
Yeah.
Good. So we have negative 42 because that became a 7 and multiplied. X comes out,
Y to Y squared.
comes out, and then who's stuck in jail?
And
Perfect. Plenty of time. Are there any others that catch your eye? If you have a question on it, it's worth me talking to you about it because I'm recording and then maybe someone would watch this and get some help. So it's up to you. I feel like we covered a lot there.
yeah, number 47.
47, sure. And then I'll probably just delete the first period recording because this has way more for someone to get. So I'll just get rid of the one and put this one up. So I have a jailbreak early, -2, which
Right.
no big deal. And then I have a number that is not on the red list, 128.
Right.
And then I have an odd U and then an odd V. Great. So we're going to have a whole bunch of stuff stuck in jail when we're done with this problem. So how are you breaking down 128?
64.
Oh yeah, 64 times 2. So we're going to get a red 64 and a boring white 2. What are you going to do with that U to the 5th?
You'll take it U to the 4th and U.
So,
And then you'll do V squared.
and we see that's the best we can look for there is just that distinction of what's coming out and what's not. When 64 breaks out, what does it become?
8, but then times
-2.
or negative 6.
Who else busts out?
U to the 4th, which would be V squared. And then and square root 2.
Good. You think that's good? All right, I'm stopping the recording then. So.